This is Misako Kachi from JAXA Observation Research Center. I'd like to make a brief report of the status of the JAXA's RDAC and the agency status. Okay. So this is the JAXA's Japanese the satellite schedule, the launch schedule. Currently we are operating the two satellite mission related to SST. It's one is a GCOM-C SGLI. It's an optical imager, and also the AMSAT-2 on GCOM double satellite. And we are now preparing for the launch of the AMSAT-3 on GOSAT-GW in next Japanese fiscal year 2024. Okay, so here is the list of the JAXA's GRIST data sets, and here is the red color indicating the update from the last year's meeting. We are updating the AMSAT-2 data in version 4.1 in July 2022. It's reflecting the I think that I already explained what kind of that update in last year's meeting, and also we updated the Himawari 8 and Himawari 9 SST in December 2022. It's kind of corresponding to the transfer from the Himawari 8 to Himawari 9. I will explain this one later. The other data, GMI SST data and the GCOM-C SGR data is also distributed from our website. The JAXA's the GRIST formatted product is available from the two servers. The one is the Himawari monitor. It's only for the Himawari SSTs, and it's also the GRIST server, JAXA GRIST server. This one this one distributes the other SST except the Himawari data. And currently we are working for the response to the RG task sharing requirement. This is investigating within JAXA how we can apply the connection to respond to this requirement, and also that we due to the hardware replacement of the web and FTP systems scheduled in next year. Actual implementation will be conducted in the next fiscal year. And the GCOM-C SGLI is a nominal mission as phase was just completed in December 2022, and the GCOM-C is currently continuing its observation as an extended mission phase. And for the Himawari 8 AHI and Himawari 9, and switchover from the Himawari 8 to Himawari 9 was conducted on the December 2022, as I explained in the previous speakers. And the Himawari 9 SST version 2.1 is now available from our website, and with 3 months overlap with the Himawari 8. So since the calibration table used in the current version 2.1 is produced only from the autumn data in the overlap period, so we will recreate it using the data in all season later. And also we are also planning the recalibration of SST using the whole period from Himawari 8 to Himawari 9, including the correction of the decreasing trend found in Himawari 8 SST. Okay, here is a response to the switch over from Himawari 9 to Himawari 8. So we conducted algorithm tuning in this the Himawari 9 data. So for the SST algorithm, calibration table was produced using the overlap period from the September to October 2022, and the product version 2.1 was released in December. And the same table was provided to the JMA, who also produced the SST in their system. So recreation of the calibration table we conducted in this year using the 1-year observation data as explained in previously. And also that we distribute the solar radiance and the chlorophyll A concentration data. So calibration coefficients are also modified. And we released the product version 2.1 in December 2022. The lower left panel show the frequency distribution of difference between the Himawari 9 and the Himawari 9 SST and the NOAA ICAM SST data. in and the before left one is a before calibration, and the right one is after calibration using the new table. And as it shows the quite a good fit to the no icon data in with the collected new table calibration table. And the right figure is the Himawari 9 chlorophyll A data, and the left one is the chlorophyll A without vicarious calibration, and the middle panel showing the with vicarious calibration. And the right figure is the Himawari 8 chlorophyll A for the reference. And you may see after we are applying the vicarious calibration for Himawari 9, chlorophyll A product will show a quite similar distribution to the Himawari 9, Himawari 8. Okay, so AMSHA 2 update. So SST for the 6 GHz, 10 GHz, and multiband SST version 4.1 was released in July 2022 to correct the decreasing trend in Northern Hemisphere. And the precipitation version 3 was also released in October 2022. And for the AMSHA 3, so it's how now we are developing the AMSHA 3 to be launched in Japanese fiscal year of 2024. And the GOSAT GW satellite system is critical design review, was just completed in October 2023, last week. And currently, and the spacecraft integration has been started, and the AMSHA 3 flight component are manufacturing and the testing. So the near real-time data distribution for the AMSHA 3 will be available same as the AMSHA 2, and the product will be released to the public about 1 year after the launch. So early data access will be available to the selected PI, principal investigators by the research announcement and the partner agencies during the calibration and the validation phase. So next research announcement. So URA 4 for JAXA's Earth observation mission, including the AMSHA 3 and the GCOM-W, will be called in the summer of 2024. So if you are interested in to become the member of the science team, please contact me or look at our website. So for the others, and we are also producing the NPP Veils SST, and they also, but this is not in a GDS format. And we plan to switch our processing system to NPP to JPSS in near future. And this the dataset is also distributed from our website. Okay, so here's the overview of the GOSAT GW, the TANSO 3 and the AMSHA 3, which carrying the AMSHA 3 and the TANSO 3. So AMSHA 3 is a successor of the AMSHA 2 mission, and but the TANSO 3 is also a successor mission of greenhouse gas observation in GOSAT 2 and TANSO 2. So here's the channel set of the AMSHA 3 sensor. So AMSHA 3, I left one the actual AMSHA 3 sensor in production and photo taken by the Tsukuba Space Center this year. And now we are adding the 4 new channel, 10.25 for the improving the temperature resolution in high resolution SST, and also the 3 high resolution high frequency channel in 165 and 183 to get the snow for retrieval and water vapor in high levels. And we also needed to modify the center frequency and the bandwidth of the 36 GHz channel to reduce the possible risk of radio frequency interferences from the 5G communication systems. And here's the image of the AMSHA 3 the antenna pattern measuring test, and in the AMSHA 3 main reflector and the feed, and within the radiation characteristic and the channel of the below 89 GHz were verified during the test. And we are also working on the component for pro-flight test and acceptance test and combinational test, and also the AMSHA 3 pro-flight test. So this test is almost completed. So here's the one of the data pics from the SST global SST highest SST observed in by the AMSHA series. So since, as you know, since March 2023, monthly global mean SST has recorded the highest value during the AMSA observation starting from 2002. So the left figure showing the seasonal variation of the monthly global mean SST by the AMSA cities from 2002 to 2023. So 2023 is indicating in the red color. So you may see, clearly see that the 2023 is a quite high SST temperature was recorded. And it's in September, it's this status is still continued. Also, SST near the Japan area showed a quite high SST than the usual, partly due to the northward shift of the coastal current. So left figure is a comparison of August SST for the lowest one in 2002, AMSA E by observation by AMSA E, and the highest one in AMSA 2. So this is the SST anomaly. So you may see that in this year, so El Nino status is is now continued. So TC surface temperature in equatorial Eastern Pacific region is quite high. But also you may see in near the Japan area, it's quite higher SST. It's more than 5 degrees than normal. It's recorded. So this is the lower right figure is a temporal variation of SST anomaly near the Japan from 2002 to 2023. So you may see the red circle indicating the August. So last August in 2022 is also quite a high temperature, but then in 2023 is also continued the higher temperature status. And so these are the information that you can quickly get from the AMSA Environment Viewer website. So quick image of the AMSA series and the 5-day running mean, monthly mean and monthly mean, and the anomalies can be displayed in new version. So you can also modify the color scale. So I think that that's all my presentation. Thank you very much.
Great.